So it's a real pleasure to talk to you. As Stephen mentioned, I have the opportunity to start a new center here at Penn, which doesn't have a precedent in the US of having a center dedicated to neurosthetics. And so this is a kind of, in some ways, a coming out party for me to talk to people at Penn about what we're doing. And so the reason I talk about this as aesthetics of people, places, and I added things, is that you can imagine this question of aesthetics through a lens of the visual nervous system. One can approach this in different ways. There's certainly auditory neurosthetics. Music cognition is a very big field unto itself. But you could imagine a way into aesthetics from every sensory modality. So you could imagine there would be a neurosthetics of perfume, a neurosthetics of taste, and so on. But since we're interested in the visual system, that's how this is organized. And you think of the visual system as classifying the world into people, places, and things. And that's at least one entree into thinking about this. So you might wonder why, in a talk on aesthetics, that I would start with the image of someone who's so dour looking. This is Gustav Fechner, and he lived in the second half, or lived in the 19th century, but came into prominence in the second half of the 19th century. And the claim is on October 22nd. It's a very precise claim, which makes me think it's probably apocryphal. But the claim is on October 22nd, he woke up with an epiphany. And the epiphany was the following, which is that properties of the world were systematically related to properties of the mind. And he went on to develop this, and in 1861 wrote a book called The Elements of Psychophysics, which is really cashing this idea out. Properties of the world are systematically related to properties of the mind. At the same time, he realized if that proposition is true, it had to be mediated through the nervous system. And he recognized that in the late 19th century, that they did not have the tools to really address this. So he separated out what he called an outer psychophysics and an inner psychophysics, and predicted that at some point in the future, which is now, that we would have an inner psychophysics in which the claim is that properties of our nervous system are systematically related to properties of our mind. And then there was a third proposition he came up with, or a third claim, which led into a book that he wrote in 1876, which has never been translated into English, except for the title, which is a primer in empirical aesthetics, in which his claim was that one could have an aesthetics from below as opposed to an aesthetics from above. And what he meant by that is, rather than argue from first principles, the way it had been done for many years in the humanities, of what aesthetics should be, or what aesthetics ought to be, or what aesthetics might be, he thought you could have an experimental program of this, and that there could be an aesthetics from below. And so in some ways, neuroaesthetics is the fleshing out of these three claims that Fechner made 150 years ago, which is that properties of the world are systematically related to properties of the mind, that if this is true, it has to be mediated through the nervous system, and that one can have a programmatic research in aesthetics that is empirically driven and experimentally grounded. So when you think about this domain, this is a kind of framing slide, which is one can think about the cognitive neuroscience of aesthetics as overlapping with, but distinct from, the cognitive neuroscience of art. And then within that, one can think about the cognitive neuroscience of beauty, which at least has perhaps received more attention in the last 15 years, but the domain is certainly not confined to that. So this is a kind of framing slide of what it is that this field purports to study. The other question is, how do you take something that is so broad and so fuzzy and deconstruct it in a way that one can have a programmatic line of research? And so for that, one of the things that there have been a number of informal models and frameworks that have been suggested. This is one thing that Ocean Vartanian, who's in Toronto, and I have written about, which is, we refer to this as the aesthetic triad. And the basic idea is that aesthetic experiences are an emergent property of interactions of fairly large-scale neural systems, which have to do with what are the properties and the constraints of our sensory and motor systems. And I'll just give you a trivial example in a way that this makes sense. One can have an aesthetic experience of a sunset. But it is the case that whatever the infrared spectrum of the light that is emanating in that scene is something we don't have receptors to apprehend. And so there's something out in the world of which we do not have an aesthetic experience under typical circumstances simply because of the design of our nervous system. And so you take that idea and extend it and say, what other ways are our aesthetic experiences constrained by, guided by, informed by our sensory, the properties, the biology of our sensory and motor systems. The next part within this triad is what is the relationship of these experiences to the way in which our neural system organizes our emotions and our valuation. Right? Often when we're talking about beauty, we're making a value judgment. Right? What is the nature of valuation and its relation to other emotions in this kind of experience? And the final piece around this is how does knowledge and experience in our semantic systems, our memory systems, interact with this to influence the relationship between sensory motor systems and our emotional systems. And so that one can imagine ways in which where you grow up, your cultural history, your personal history, if you grew up in a family that was where you were exposed to a lot of art versus not, if you grew up in the 15th century versus now. So there are a variety of ways in which how we experience aesthetics is informed by our meaning and knowledge systems. And so if one is to then decide, one is to design a programmatic approach to this, basically you just carve out, like every scientific enterprise, you carve out bits and pieces of this and try to flesh out what that might mean. And at the end of all of that, hopefully you come up with a relatively coherent but never complete understanding of what the phenomena under consideration are. To give you a sense of how young a field this is a PubMed search I did with, I think I have the terms up there, which is a search for neuroaesthetics, a search for neuroscience of beauty, or neuropsychology of beauty, neuroscience of art, neuropsychology of art. And you can kind of see the number of publications from 1965 to 2018. And basically, around 10 years ago, maybe, there's a sort of inflection point where these numbers are starting to increase in a dramatic way. The point of this slide is this is still an extraordinarily young field. And particularly for students in the audience, I'd like to point out that big, obvious questions have not been addressed. Right? This is not a field where we are debating how many angels are dancing on the head of a pin. We don't even know where the pins are. Right? So the big questions, and more often than not, in talks like this, in the Q&A part of the talks, people ask me questions, and often my response is, great question, nobody's done the study, do it. Right? So just I'm prepping you for what my answer is going to be to many of your questions. But the broad point is that this is a young field, big questions remain to be answered. So a standard question I get is, isn't beauty in the brain of the beholder? And when people say that, often what is implied by that is beauty is so variable, you can't have a programmatic line of research around beauty because everybody has their own tastes and it's completely chaotic. Well, the question is that true? And in some ways you can say, the response is, what are we talking about? Beauty of what? And so this is to give you an example of when it comes to faces, people tend to be really quite consistent in which faces they regard as beautiful. On the other end of the spectrum is, when it comes to art, people are very inconsistent with respect to what people judge as beautiful. But in between that, you have natural landscapes, which are closer to faces, and then you have architectural interiors and exteriors. And those seem to fall somewhere between art and landscapes, and you can think of architecture as a kind of manufactured landscape. And so the big picture point about this is that natural kinds, faces and places, we tend to be more consistent, and artifactual objects, we tend to be less consistent. And I would point out that lack of consistency does not mean that one can have, lack of consistency does not mean one cannot have a scientific enterprise, right? Part of what scientists do is try to understand variance. So if you have a lot of variance, the question is, what's the structure of that variance? And so we'll come back to that. So what I'm going to do for the rest of the talk, again, is to focus on people, places, and things in this case will be artwork, and just give you a flavor of some of the kind of work that we're doing in each of these domains. And in each section also end up with some ways in which this research translates beyond the confines of the laboratory into areas that might have some notable impacts on society, since we are here talking in the context of neuroscience and society. So starting with faces and beauty in faces. When we ask people questions about beauty, often the most typical thing people will think about is are people and people's faces. We have these kinds of popular expressions of this where, People magazine will do their whatever 10 or 50 people, most beautiful people every year. This gets a lot of attention. And it turns out that there is a kind of to use Fechner's terms, there is an outer psychophysics of beauty, of facial beauty that seems to apply broadly, which many of you probably know about. So symmetry is an example that people generally tend to find symmetric faces more attractive than asymmetric faces, to a point. If the faces are absolutely symmetric, which you can now do with digital imagery, that people get a little creeped out by it. There's a whole weirdness factor around that. But just shy of that, if you're in general, people tend to like symmetric faces over asymmetric ones. There's something called averaging, and this has a rather interesting historic antecedent. And the historic antecedent has to do with Sir Francis Galton, who many of you may know is a cousin of Charles Darwin. And in 1868, he was giving a talk to the Anthropological Society of England and Ireland. And let me step back one before I tell you what the talk was about. Galton was a polymath. He was an anthropologist, he was an explorer, he was a statistician. It turns out he was also a eugenist. And this is before the term had the same kind of connotations it has had since then. And so in this talk, what he thought he was doing was he would bring to bear an important social issue. He would bring to bear modern science to address an important social issue. And modern science at that point, modern technology, was photography. Photography was discovered in the 1830s, this is in 1868. What he thought he could do is if he took photographs of convicted felons, convicted criminals, and overlaid them and created a composite image of these criminals, what he would get would be the prototypic image of what a criminal looks like. And that this would be useful. This would be useful for law and order and so on and so forth. So in this address, the last paragraph of his address is wonderful to read, which is he ends up saying, to his surprise, that what the image that came out of this was not someone who looked like Jack the Ripper or Moriarty. In fact, it was someone who looked very attractive. And it turns out this, as an observation, as a laboratory observation, tends to hold up using modern methods. And so the basic idea is if you take 16 faces or 32 faces or 64 faces, combine them digitally, you get the average of those faces. Almost invariably, the average face is more attractive than any of the faces that contribute to them. And then the third parameter that seems to play out on an outer psychophysics of facial beauty, and these are mostly heterosexual norms, because that's where most of the research has been done, has to do with the physical effects of estrogen on women's faces and the effects of testosterone on men's faces. The kind of features that are rendered by those hormonal influences tend to be regarded as attractive. So that's all kind of the outer psychophysics of facial beauty as best we understand it. But what happens in the brain? And so this is where I'm going to take you next. This is a study that I did here with Jeff Aguirre. This was done about, I think we did it about a dozen years ago. And it's an fMRI study where people came in on 2 different sessions into the lab to be scanned. And in one condition, they were making a judgment of beauty. And in another condition, they were making a judgment of identity, which is, had they seen this face before or not? And these are all computer-generated faces, so we can manipulate how similar or dissimilar they are and have some control over the difficulty on the identity question. So that's the basic setup. There are 2 different times that people come in. These are the main findings, which I'm just going to focus on the bottom. For those of you who are not used to looking at brain images, we are looking at the underside of the brain. At the bottom here is the back of the brain, the occipital cortex. The front is at the top. And on the left, what is being depicted are regions of the occipital cortex of our visual brain that seem to be relatively tuned to different kinds of objects. So what is being shown in red is an area called the parahippocampal place area. It's part of the parahippocampus, which Russell Epstein is sitting here in the audience as one of the first discoverers of this part of the brain, where this is an area that is responsive, more specifically to places, different kinds of both built and natural environments. As distinct from part of the fusiform gyrus, which is depicted in yellow, that seems to be more responsive to faces, which is distinct from this blue area, which is sometimes referred to as area LO, which seems to be responsive to objects. Okay, so that's just a property of our visual nervous system, which we then use to try to ask the questions that we're asking. So in the middle panel, what we find is that when people are making a judgment of beauty, and I'm just going to focus on the visual cortex, not the rest of the brain, when people are making a judgment of beauty, that there is neural activity that varies parametrically with how attractive the faces are. And this neural activity is not generalized in the sense that we don't see this in the area of the brain that is responsive to places, but we do see it in the area that's responsive to faces and the adjoining area that is responsive to objects in general. If you think about it, it didn't have to turn out this way. So for example, if I told you the design of the nervous system is the back of the brain classifies things, it says this is a place, this is a face, this is an object, and the front of the brain does all the evaluation, that would be a perfectly logical and plausible way that the system was organized. But it turns out it's not organized that way. That all the way in visual cortex, there seems to be some value that this part of the brain is computing, in this case with respect to facial attractiveness. In some ways, the more interesting observation in this study is shown on the right panel here, and this is when people are making a judgment of identity. So beauty is not on the table. They're just saying, did I see this person before? Does this person look familiar? Yes or no? And what we find is in occipital cortex, there is the same kind of modulation that is not distinguishable from the kind of modulation we see when people are making explicit judgments, that there is this modulation in visual cortex to how attractive the faces are, suggesting that our visual system is responding to how attractive the faces that we confront are, even when we are not actively thinking about them. So there seems to be an automaticity to this kind of responsiveness in our visual brain. So, now around the same time, there was another group that had published this paper with a very similar intent in mind. And the way our study had been done, we were really focused on the occipital cortex. We didn't have very good signal in the front of the brain. In this study, instead of identity, the perceptual task was, are these faces wider or longer? And what they find is that even when people are looking for this broad kind of geometry of faces, that parts of the reward system, particularly in a part of the brain that is called the nucleus accumbens, which is part of the ventral striatum, and the orbifrontal cortex, that there is neural activity that varies with how attractive the faces are. So if you take both of these studies together, the implication is that our reaction to beautiful faces seems to occur automatically, even when people are not explicitly thinking about beauty. And the neural expression of that is a linking of our visual system in a somewhat specific way with our reward system. And so an expression of the experience of beauty seems to be a conjoined simultaneous neural activity of visual system and pleasure systems in this case. That is really a translation of biologically what it means to see a beautiful face, is what we think. So this question of automaticity, we were interested in how does that cash itself out? Does it play itself out into our motor systems? And so this is a very recent study I did. It's a simple behavioral study. This was with some collaborators in Singapore. It's a very easy task. It's a mouse tracking task where people start out with the mouse at the lower number. All they have to do is move the mouse to whichever number is closer to the number at the bottom, right, and click on it. Very easy task. People are always at ceiling on this. Nobody has any trouble with it. The experimental manipulation is the face that is completely irrelevant, but the face that is next to the number. And the question we were asking is, if the face that is at the non-target location, the distractor location, if that face is attractive, does that have an influence in how people move? That's the basic question. And so the way this was done is we took a whole bunch of faces. These are not supermodels. This is the kind of just the distribution of the way people look. They were normed extensively. We took the top 10% of faces that were regarded as attractive, the bottom 10% were regarded as less attractive, and in the middle were the ones that were, in our case, regarded as neutral. And so what we find is this, which is, it is the case that if the attractive face is by the number, which is not the target, people's limbs kind of drift in that direction before they go to the actual target. And so what's shown on the left over there is a summation of one participant's data to give you a sense of this. And when they're debriefed, people are not aware of this, right? So there is a way in which just the notion of attractiveness is not really a metaphor. There is something about this that is driving our motor system to move towards a face that is attractive in a way that people are not really conscious of doing. So we also did, in this study, we did an eye movement study with exact same setup. And here we're looking at where are our eyes drawn and what is the fixation time. And here we see something interesting and is a bit different. I'm just going to focus on this over here because I think that tells the whole story that I want to tell, which is in this case, the eyes of the participant are drawn both to the attractive and the less attractive, the top 10 percentile and the bottom 10 percentile of the faces, and that there's no real difference in how their eyes are drawn to either of those. So what does that mean? What we think it means is that our motor systems are expressing two different kind of phenomena, that our limbs are expressing what we think is an attraction response, but our eyes are reacting, the motor systems that control our eye movements are reacting to things that are on either end of the spectrum, as though this is a kind of vigilance response. And so, just to be clear, it's the exact same information that is coming into our occipital cortex, into our visual system, and that information is being sent out to the motor system, but the motor system separates it out for two different kinds of functions. There's a vigilance function, there's an attraction function, is what we think. So moving along, if it is the case that we have these kinds of automatic responses to beauty, what are the social implications of that? And one implication that has been quite well described in social psychology is that there is a kind of beauty premium, that people who are attractive get all sorts of advantages in life, unearned advantages in life. And this can, this includes things like getting hired more easily, receiving higher pays. Attractive people that commit crimes are given lesser punishments. Students who are attractive are typically given higher grades unless they're standardized tests. So there's all of this stuff that comes along with being attractive, and the idea is that there might be, and this is something that Greeks have talked about, there might be a beauty is good stereotype, and that there's a conflation of these valuations, the valuations of a moral judgment and aesthetic judgment, that there is some kind of conflation that seems to happen. We're not very good at discriminating these kinds of values. And so the question is there a biology to this? And there have been at least 3 studies that I know of, but this is just one example of a study that was done in South Korea, where in one condition, people are looking at faces and making attractiveness judgment. In the other, in the top, they're shown these little cartoons, and these little cartoons are of what most people would agree is a morally good act. In this, I think the example is a child helping someone who is blind down some stairs. Most people would say that's a good thing for the child to be doing. And so they're making these judgments, and the point of this study is that they find within orbitofrontal cortex, one of these classic areas of valuation and reward, that there is converging neural evidence for both of these kinds of judgments. The rest of the brain is doing different things in both judgments, but at least the implication is that there might be a biologic anchor for this beauty is good stereotype. So we got interested in this in sort of looking at a complementary question in the context of being in a medical school, which is that there are people who have various kinds of facial anomalies that can be surgically corrected. And so here's an example of some of the stimuli we ended up using. This is a study that was led by one of my postdocs, Anjan Chatterjee. You can see in the top there's someone with a cancer on her skin. You can have scars. You can have various sorts of stains, port wine stains. But the general point being that if it is the case that someone has this kind of anomaly, is there an analogous facial disfigurement or facial anomaly is bad bias that we have? That's the basic question, right? The beauty is good stereotype has been well demonstrated across a variety of studies. And what we end up finding is potentially quite depressing, but it is the case that, so this is an online survey. People are only seeing one face. They're not seeing both faces and making relative judgments. They're just looking at a face. We ask them a bunch of questions. And it turns out that most people in the aggregate, when you see someone with these kinds of facial anomalies, you think they're less intelligent, less hardworking, less competent, less trustworthy, and so on. And and that this ends up being really quite robust. And when we sort of do some principal component analyses on these, it looks like it follows something that psychologists know is the kind of 5-factor personality structure. So it really looks like when we are looking at faces, we are making assessments of people's personality given no other information, and that this is affected by how people look. And if people have facial anomalies, we attribute to them negative personality characteristics. That's the basic finding. Turns out that this observation, once you pay attention to it, is all over our culture. And this is just to give you an example of how popular media makes use of this, that if you think of many of the villains in Bond movies or Marvel movies, even The Lion King, I mean, in The Lion King, the only character that does not have a name is the villain, and his name is his deformity, his scar, right? And this is the message we're giving our 3- and 4-year-olds. So this is something that you end up seeing all the time because it makes it very easy. You don't have to develop a backstory. The message is clear. If someone has a deformity, more often than not, if someone has a deformity, that they're going to be a villainous character. So I think it capitalizes on these kinds of findings. So we went on with this, and this is a study that the next couple of slides that Franziska Hartung, who's here, sort of led. It was a follow-up on what Anja did. So many of you have heard of the implicit association test, which is the general idea is that it's been done in race studies and gender studies, and the task is also a very simple one, which is you've got a face, you just have to classify it by moving your limb in one direction or the other. So in this case, a face comes up, people say it's a typical face, they click in one direction. It's an anomalous face, they click in the other direction. Very easy task. Separate from that, there are words that show up, and they just have to respond in one direction if it's a positive word or a negative word. Again, very easy task. And what the logic of the experiment is that if people have a negative association with a certain kind of face, and if the motor response is the same for both of those things, you respond more quickly. If there's no association, there should be no reason why your motor system should be primed. It should just be random. And so that's the way this task is done. We also developed an explicit questionnaire where people were asked if you have biases against individuals who have facial anomalies. And this is what we find, which is that on the left is the explicit questionnaire, that people's responses are not different than 0. So generally, as a group, people don't think they have these kinds of biases. But if you look at the effect sizes of their implicit association test, they're quite robust. It also is the case that men have, the effect sizes are greater among men viewers than among women viewers, and that's something we've replicated, so this seems to be true. Furthermore, if you correlate people's self-reports about their explicit bias versus their implicit bias, there is no correlation. So I'm going to extend beyond the data now and make the claim that everybody in this room harbors certain kinds of implicit biases. They're not the same ones, but everybody probably harbors implicit biases, and we are terrible judges of our own implicit bias. So that's extending beyond the data, but this is my public service announcement. So the next piece of the study was, well, what's going on in the brain when people are looking at these kinds of faces? And so this is a study, again, it's using the same set of stimuli. All people are doing in the scan are saying, I think that's a man, I think that's a woman. They're just making a gender assignment judgment. And what we find in the brain, I'm just going to point to 2 specific findings. That if you look at the occipital cortex, again, this is down here, we see that there is greater neural activity for these kinds of anomalous faces as compared to the typical faces. So if you go back to the study we did 10 or 12 years ago, we got the same kind of neural activity in approximately the same area to beautiful faces. And at the time, I think we misinterpreted those findings, thinking that maybe we had these automatic beauty detectors. Well, that doesn't make sense for occipital cortex, because then you should have increased neural activity for anomalous faces. And so now what we think it is likely the case that our visual system is really responding to faces at the extreme. It can be beautiful, it can be anomalous, things that are at the extreme. And so this kind of vigilance response that I mentioned, I think is being cashed out in the visual cortex in that way. But in some ways, what was even more interesting is this area in which we have less neural activity for these anomalous faces. And this part of the brain is rather interesting. It's part of the medial prefrontal cortex, anterior cingulate. And on one account, this part of the brain is important when people are put in conditions of empathy for others. And so there's a neuroscientist at Princeton, Susan Fisk, who has argued that this pattern of deactivation in this area might be a biomarker for dehumanization. And so the way in which when we're looking at these kinds of faces, that we have a tendency to sort of treat them, to view them as less than human, and this might be the biomarker for that. So this is something that we are now exploring and trying to deconstruct. What is this notion of dehumanization? What plays into that? How do we understand that? Cliff Workman, who's sitting here, is picking this up and doing some studies around this, where the broad agenda is trying to understand whether individual differences, dispositional differences, how we view the world, does this have an effect on how we end up thinking about people with these sorts of facial anomalies and modulating neural activity. And just as some of the data that he's been looking at, these are all very preliminary data, which we're in the process of analyzing right now. Just to give you one tantalizing piece, this is the ventral striatum. This is, again, one of these classic reward system areas. And it looks like the kind of neural activity that we're seeing in the ventral striatum when people are looking at these sorts of faces in a different paradigm is modulated by what kind of the effect sizes that we see in their implicit biases, and also on a questionnaire that we've been using several different kinds of questionnaires. One is about the different kinds of disgust responses, and that there's a subcomponent of the scale that is about moral disgust. And people who rate highly on a tendency to experience moral disgust, that tends to modulate how neural activities in these reward systems. So again, this is something that is ongoing, but the strategy here is now, here we have this kind of finding that we're trying to understand what is contributing to this finding, and further, how does this cash out in behavior? And so we have a number of studies designed to look at that. Does it mean that you treat people differently? So you have these biases, but you actually treat people differently, and that's something that we're looking at. So I'm going to switch gears, as I said, people, places, and things. And now, so this is an ongoing line of research. We're going to switch to places, and some of you may recognize this particular interior. A couple of years ago, I was giving a talk in Barcelona, and I just had one extra day to spend there. And so my plan was, as soon as it opened in the morning, I was going to go to this cathedral by Gaudi. This is Sagrada Familia, for those of you who recognize it. And I had my whole day planned out. I was going to go there, I was going to spend 2 hours there, then I was going to move on to the next thing, so on and so forth. So I get there when it's open, and I left when it closed. Right? I spend the entire day in this place. And the kind of, for those of you who have been in this place, it can be an extraordinary experience of the kind of emotions it brings out. And so the broad question is, how is it that our built environment that we inhabit, and most of the developed world, we spend 90% of our time within the built environment. How is it that the built environment has an effect on us that can have an effect on our mood, on our sense of well-being? So, big question for the first section was, what's the relationship between beauty and morality? For this section, the big question is, what's the relationship between the built environment and our sense of well-being? Okay, so that's the broad agenda here. If you go back to how people have thought about architecture, this is from Vitruvius, who was a Roman soldier. He, in the 1st century BCE, actually wrote a 10-volume treatise on architecture. So it's a little silly to reduce this 10-volume treatise on architecture to a simple triad, but that's what I'm going to do. And so his triad was basically that when one thinks of buildings, one thinks about its materiality, firmitas, the kind of structural qualities of it. One thinks of its utility. Does this room function well as an auditorium? And then one thinks of its aesthetics. And arguably much of the sort of middle to later part of the 20th century, architecture conflated the utility and the aesthetics. So a beautiful building was one that functioned really well. But more recently, that seems to be, people seem to be separating out those two notions again. And again, for us, we take this aesthetic node of the Vitruvian triad and explode it into the kind of way we think about aesthetics, because this, again, is how we think this would be cashed out in the brain. And so there's a question of how, if you're a neuroscientist, how do you try to study what the experience of architecture is, what the effects of architecture on your brain is? And there are some very major constraints which we should acknowledge up front, which is that if what you are doing is fMRI studies, it's not a hidden secret, but it never gets talked about, is every fMRI study involves someone lying flat as still as possible on their back in a metal tube, right? I mean, if we were studying near-death experiences, maybe that's a great way to do it. But for everything else, especially architecture, where you're moving through space, it makes no sense to use this as a method, right, across the board. The other thing is we take two-dimensional images, which is exactly not what being in an architectural interior is, right? So up front, it's ridiculous to think we can get anything meaningful out of this, and yet it's extraordinary what we end up finding. So that's the point. So if you say, how are we going to study architecture? What we thought is we would take interiors and deconstruct them into 3 factors that apply to all interiors. And these stimuli were done with the help of some architects in Copenhagen. And the general idea is that every space, the ceilings can be high or low, the interiors can be rectilinear or curvilinear, and the interior can be open or closed. By open, I mean you can see past the enclosure versus not, right? So those 3 things. And so we did a study. This is Ocean Vartanian, I met, was the lead author on this about 6 or 7 years ago, where we just asked the simple question is, when people are looking at these kinds of interiors, and they're asked, would they want to enter this place, or is this place beautiful? Is the neural signature of beauty, is this in any way similar to what people have found for other kinds of responses to beauty? Very straightforward and simple question. And basically this is what we find, is that in parts of this medial prefrontal cortex, in ventromedial prefrontal cortex, again, areas that commonly show up, that we see a response to beauty. Okay, very simple point. So this is in the kind of backdrop to this. So we went back. I had an architecture grad student from Cambridge who came to my lab, a guy named Alex Coburn. He wanted to do some of his empirical work in my lab. And so we combed through the literature of the kinds of questions people ask about landscapes and about built environments. And we came up with these 16 dimensions that have typically been asked And so we did a large online study. So we have 200 images of these interiors, which is what we used in the original fMRI study. We asked 800 participants to rate each of these images along these dimensions. So when you do that, what you can get is this sort of correlation matrix, which tells you if someone says something is interesting, do they also say it's complex, and so on and so forth. So it allows us to kind of see what the distribution of how people respond to these attributes that they're impugning onto the image. So from that, one of the postdocs in my lab, Yoed Kennett, who does semantic network analysis, took this correlation matrix and sort of created this kind of network analysis. And I can't claim that I understand the math behind this, but basically what it is a way of showing how close each of these items are to each other based on how similar people are in their responses. Right? So it's a spatial display. And what we end up finding is that there are these kind of 3 different communities of response, of which valence is right in the center, which is the most basic thing of do you like something or not like something. So we're calling these three communities of responses coherence, fascination, and hominess. And I'll come back to maybe what those things mean. So we then go ahead and do a more traditional principal component analysis. That ends up showing the same 3 components. We redo the whole thing in a brand new group of people to convince ourselves that this is actually true. It turns out we replicate the same finding. And then the final step is, so now we have these behavioral data which suggest that these 3 components seem to be important. Coherence, which is how coherent, how organized does the space feel? Fascination, which is we think is, do you feel like you want to explore? Do you want to enter? Do you want to find out more about this place? And hominess, which is, do you feel comfortable? Does it feel like you belong there? Right? So these 3 things which seem to be orthogonal to each other seem to be part of the psychological response to architectural interiors. So we go back to that original study we had done that was published in PNAS in 2013. So that was a study that was done in Tenerife. So these are Spanish students. That fMRI study was done there. All of these data were collected here in Philadelphia. And we go back to the study there, and it's as good, I think, a double-blind study as you can have for an fMRI study in the sense that we didn't know that these components were relevant when the data were collected. The participants weren't asked anything about these components because we didn't know they existed. And we went back and remodeled their data based on these components because it's the exact same stimuli that were used. And what we end up finding is within occipital cortex that there is differential neural activity if the neural signal is modeled along these 3 components. And there are some nuances to that I won't get into, but at least for us, this gives us some confidence that these have a kind of both psychological and a neural reality as 3 components. It doesn't mean those are the only components, but that there does seem to be something that is grounded both in our psychology and our biology about our responses to architectural interiors that follow along the notion of coherence, of fascination, and of hominess. So one practical consequence of this, or practical follow-up to this, is I have the opportunity to work with an architectural firm in Philadelphia called Ewing Cole, and we are in the process of designing a memory residential care unit in Quakertown, which is, it's in a flat piece of wooded area. There's no structure. We're building this from the ground up, and what we're trying to do is combine some of these neuroscience principles along with the general principles that architects might use. And to just, we've had at least a dozen, if not more, meetings together to work out these ideas. The architects and their lead design people and their research people have come to my lab 3 times. to work some of this out. And just to give you a flavor of some of this, this is the kind of design that we've arrived at, which is, again, thinking of the kind of, when you talk about sensory motor properties, the question is, what are the kind of motor behaviors that one sees in people with short-term memory problems? And one very common one is wandering. And so what happens typically in most residential units for this is we place barriers on them. You lock doors, and then if people get upset, you give them tranquilizers. That affects their motor systems. They fall and break their hips, and it's a kind of downward spiral that is extraordinarily common. So our idea is no barriers. Let's let them walk as much as they want. And so one idea is that we have this kind of circularity, which is they're in the hallways. They can walk till they're exhausted. They'll never get lost. When the weather is nice, we have this interior, which they can go out. It'll be nicely landscaped, and they can walk as much as they want, and they're completely enclosed, right? So that there's no way of getting lost. And there are a bunch of other things that we've used from these ideas. And just to give you a kind of rendering of this, there are some of these common themes that we carry in the interior and the exterior, so to kind of give the sense of coherence. The landscaping and how we're structuring the pieces will address some of the issues around fascination, so people are stimulated if they wish to be. And then on the hominess front, so this is in Bucks County, so we're using materials like wood and stone that are very typical of that area. And just here's a very little detail, which is that in the early renditions of this was very angular, and it felt jagged in a way that once we started emphasizing the notion of hominess, it became obvious to everyone that those needed to be more curvilinear than rectilinear. And so this is a way in which some of these ideas that we get from the laboratory are starting to get implemented in the design of a home that is going to, we hope, make a big difference. And one thing to point out, in the final design, this little bit here is supposed to be a research office, and so the idea is that I would be able to have myself or people from my lab actually be there if we want to collect ongoing qualitative data and some quantitative data of what's happening to people over there. Okay, so now, final switch. We don't have much time. This is the shortest segment, which is things, and in this case, artwork. So, going back to this original question of how do our sensory and motor systems have an influence on aesthetic experiences. You'll recall in the earlier part of the talk, we talked about how beauty has an effect on our motor systems in a way that might be differential on the motor systems that guide our limbs versus that guide our eye movements. Here the question is turned on its head a little bit, which is how do the properties of our motor system affect our aesthetic experience? And in this case, this is a study that Stacey Humphreys is leading. We're still in the process of analyzing these data, but what we have so far is really quite intriguing. And the question is, if someone has a motor impairment, does this affect their aesthetic experience in any specific way? That's the basic question. And to address this question, we looked specifically at abstract art, specifically at Pollock and Mondrian's. And the reason for doing that is you get away from questions of representation. So if someone really loves landscapes, or someone likes portraits, or someone likes still lives, that we're not dealing with any of that. So these are all abstract images. As you can see, these are examples of the Mondrians. These are examples of Pollock's. We have all of these paintings rated separately, and what we find is, what we hope to find, is that there's this nice kind of bimodal distribution of how much movement people apprehend in their paintings. Right? So this is exactly what we want. And so in this study, we look at 30 people with Parkinson's disease and a bunch of controls. And the basic question is, again, in people who have a motor impairment, in this case Parkinson's disease, does this have an effect on their aesthetic experiences of these kinds of abstract images? So what we find is that people with Parkinson's, when they're just rating the degree of movement in these images, their whole range is constricted compared to control participants. Right? So that's one observation. But the much more fascinating, to me at least, observation is in this slide, which is that if you look at the degree of motion in the painting as judged by normal people and liking, what you see is that people with Parkinson's have a blunted response, that their liking and their judgments of beauty never reaches the same peak as it does for normal controls. But there seems to be some degree of specificity to this, because if you look at the relationship to complexity, we really end up seeing no difference in how people with Parkinson's are responding to how beautiful they think the image is or how much they like it. And it's worth pointing out that one could have started out thinking, okay, people with Parkinson's have a deficient dopamine system. We know dopamine is important for reward systems. It might be the case that their aesthetic experiences across the board are blunted, but that's not what we see. What we see is if you're channeled into an aesthetic experience is through your motor system, in that case, for these individuals, there is a blunting of their aesthetic response, but if it's about visual complexity, they're okay. Right? So it tells you something about the sort of specificity of how when I was talking about these sensory motor systems, the specificity of how they can have an influence on an aesthetic experience. And now the final, just general, to say broadly, how are we thinking about all this? This is a very specific kind of research question, is what is the nature of aesthetic experience? The broader question we have is, what is art good for? Why do we care about art? Right? This is absolutely, in my mind, a critical question. Philadelphia Public Schools, as soon as there's budget cuts, the first thing to go are music and art. Does that make sense? Does it not make sense? Right? I don't know. But so, those of us in the choir think it doesn't make sense. But the fundamental question is, what is art good for, is something that we want to address. And then finally, we received some money from the Sachs Arts Initiative. We have Lucas Kelly, who is now an artist in residence, and we're actually together combining some of the research we're doing on the nature of aesthetic experiences and his interest in creating objects that have to play around with memory and nostalgia and the emotional experiences of memory. And so we're using him to kind of force us, so it's one thing for a scientist to go in and say, this is what happens with art and all of this sort of stuff, but then we're hoping to use an artist to kind of push our thinking about how we even think about what it means to be engaged with the arts. So that's a kind of broad overview of what's happening in our center, and the kind of broad, again, the three big questions that we are hoping to address over time is relationship between beauty and morality, the built environment and our sense of well-being, and what is art good for?